Fiona is a master quantifier and awesome, inspiring nature journaler, and is my nature journaling and sketching buddy. Today, the two of us are going to be working with you to show you just how much fun it is to quantify in our nature journals. And you may be thinking to yourself, like, I'm not so much a numbers person, I'm not so much a math person. But here's the deal. So numbers, it's just another language for describing the world around us. And it is as beautiful as you will see and as rich as the world that it describes. And when we give ourselves permission to dance with these numbers, there are patterns that we otherwise would not see that come out to play with us, right? And it's going to be a good old time. Is there anything you want to say in introduction, Fiona?
Sure. Yeah, I don't really like math in school. I've never really been a math fan. I don't think I'm that good at it. But I have had a lot of fun doing math and quantifying in my journal. For a solar eclipse, I was voluntarily doing trigonometry, which is something I never thought I would do. And now there I was, and it was really fun. So it's really nice to have some meaning to it, to have like you're solving for things that you can relate to. It's not just a math problem in a book. You're finding the height of this tree, and suddenly it means something. So that's been really fun.
And we're going to have fun today. So I want to. So we're going to be kind of ping ponging off of each other, um, and it's going to be a good old time. So here we are. I'm going to hide the floating meeting controls. And all right. So this is our introduction page. That's us. So Fiona and I, we are journal buddies, and we kind of push each other to kind of innovate in our nature journals. And whenever I get stuck, Fiona's the person I call, and she's kind of my support line to kind of get me going again. You think that if you're me, you don't get stuck and kind of blocked in your nature journaling, but I do too. And having people that you trust and know and support you to help you get unstuck makes a big difference. So thank you for unstucking. Today, this is our humble agenda. We're going to start on the column on the left with counting, measuring, timing, and estimating. And then we're going to jump over to the right with special tools and displaying and visualizing data. It will be amazing if we get through all of this, but we are going to do our best to try. And we hope that by the end of this, you're going to have a real cool bag of tricks to help you do this. For measuring, sorry, let's start with let's go in order here. For counting. So this is the easiest way to start to get numbers into your nature journal. What are some examples of things that everybody knows you can count, but maybe don't always? But what are some other kind of cool things you think that you can start to count once you realize, like, oh, I can start counting stuff, and that reveals patterns? What are some things you found yourself counting in your nature journal, Fiona?
I've counted lots of things. Birds in a field. I love going out and birding and stuff like that. Keeping tallies of like how many species I've seen, stuff like that. Counting like the number of flowers like on a bush or on a plant or something like that, and making little tables of like if it's a like a little plant that has multiple flowers per plant, to see like what's the average number of flowers in that like per plant and stuff like that.
So what I hear you doing is, so you're counting things, and sometimes you're not just counting on an object, but you'll get a category of things, flowers on a bush. You'll compare between things. So everybody check this out. What she's doing there is sampling, right? So she is, there's not just a lot of flowers on these bushes, but she's getting, flower on the bush. Then you get one, a sample size of one. But then by looking across bushes, she's getting more. We want to kind of move away from, in our journals, just saying there's lots of ducks, right? But so if I can say there's 50 ducks, right? 50 northern shovelers. That's much, much, much better than saying countless shovelers, right? Let's remove the term countless from our vocabulary, because what you can do whenever you hit that is you can start counting things, right? So when they're countless, please start counting them. Here is a little, just a little species list down the side of the page, and you can count things. Here is out on a stormy day on April Fool's Day. I went out in a thunderstorm to go explore San Bruno Mountain, and over here are the birds that I saw on the left-hand side. And you'll see that there were 6 wren tits, right? There were 40 cedar waxwing. And that is so much more useful than saying a lot of, because your a lot of is going to be different than somebody else's a lot of. And what a lot of means in 2020 is going to be very different than what a lot of means in 2040, right? So we want to start quantifying things. That's something that Ann Chadwick at Point Blue Conservation Scientist and her people are doing, is they're keeping real numbers of what kinds of critters are coming into their mist nets, and then they're able to say specifically, these things are declining. How do they know? Because they counted them. Boom. We can do it too. Oh, so this is going to be fun. Let's talk about measuring. So in talking about measuring, I'm going to jump away from this screen. We are going to go to, let's see. I am stopping sharing. And are we back to the Fiona and Jack Cam? Yep. Okay.
Yes,
So let's talk a little bit about measuring, because for measuring, if you have, all you need to measure something is a standard unit of measurement. Like if you use this acorn as your unit of measurement, you can measure with this. Something can be 1 acorn long, 2 acorns long. The problem is Fiona's acorn, different size than my acorn. How do we solve this, Fiona?
you can use a little ruler. I have a little, this is actually part of a larger thing that we'll talk about later. But this also has, I don't know if you can see it. It has little centimeters across the top. It does have inches on the other side. Centimeters are a much easier unit of measure to work with because they're all base 10. So metric system, I think it's superior. Yeah, anyway, so I measure everything in centimeters using this little ruler or the little tape measures. I don't have mine with me. I actually don't know where it is. Jack has one, yeah. So anyway, yeah. So those are really fun to use and to measure. So.
Yeah. So if you have a measuring tool with you, you'll measure things. So go put a measuring tool in your nature journal kit. So my nature journal measuring system is, I've got this for longer things. And the great thing about that is you can do this, right? So you've got that for longer things, then this, and then you've got this. And I totally agree with you about the metric system. Mad props to the metric system. It's nice to be able to, like, if I say something is 215 centimeters, now sort of translate that over into decimeters, right? We can do that actually in our head. But if I say something is 217 inches, what's that in feet? Everybody's like, ah, right? So converting, decimeters and centimeters over to meters, we can visualize this stuff. And so yeah, I'm absolutely with you on the metric system. So metric measuring devices. And it's weird to get used to at the start, right?
Yeah.
But we can.
Yeah.
We just like, buckle our seatbelt. It'll be kind of weird to sort of think of what's a kilometer. But eventually we're like, okay, yeah, I got this kilometer thing. It's like, yeah, okay, I got it, right? It's 10 of those. Now, one other thing about the metric system. thought about metric system and measuring is that when you're measuring, you want to, if I was measuring something this big, measuring the length of let's say measuring the length of a bird, and I was doing that in millimeters, the really small ones, I'm going to get a really big number. It's going to be harder to visualize. If I describe that in centimeters, people can go like, okay, I can see about like what 17 centimeters is, right? So I want to use the most appropriate unit of measurement. And something that's nice about the metric system is that they'll step up. You got centimeters, you get millimeters, you get 10 of those. You've got a centimeter, you get 10 of those. You've got a decimeter, you got 10 of those. You get a meter, right? Useful. So there are these stages. You don't have to go from inches all the way to a foot. You go from something this small to something this big to something this big to something, that big. So you want to use the unit of measurement that is the most kind of clear to you, would be a useful thing for measuring at this scale. So when you're looking at something, I'm not measuring everything in centimeters. If decimeters are more appropriate, I use that because it's just easier to communicate with. If I'm estimating the height of a tree, I'm not going to convert that over to centimeters. That would be crazy. I get a big number and the level of precision would be inaccurate. So I'm going to use whatever system is whatever unit is going to make the most sense. But here's the thing that drives me nuts. There is incredible discrimination against decimeters. Why have we lost the decimeters? I don't know. Like everybody's doing centimeters, millimeters, and meters. Who's measuring in decimeters? But it's this other unit in there that is equally useful. So do make friends with decimeters. So I want to invite everybody here to fall in love with decimeters. Right? Do you want to add anything to that, Fiona?
Yeah, just that no one uses decimeters, and it's sad.
It's tragic, isn't it?
I had never heard of them before. So
yeah, so what it is it's a unit that is this big, right?
Right.
Here's the cool thing for me. This length is exactly a decimeter. I can measure decimeters hand to hand to hand to
with
hand.
your hands. Wow.
Oh,
hold up.
Boom.
Now I'm curious.
Isn't that fun? I can do decimeters that way. So I can do like 1 potato, 2 potato, 3 potatoes with my thumb included. That is, I put that down, and when I do that side to side, that's 20 decimeters. I mean, 2 decimeters, 20 centimeters. Wow. Nice. All right. So yeah, do make friends with decimeters. They're cool. Right? But wait, there's more, right? So measuring things. Here we go. Because sometimes your little ruler is not long enough, is it? And this is where, so here's just a little bit about measuring things. Look at this cute little salamander. So there are measurements all over this page. And so what I've got here are some relative measurements here. So you see this 1:1. This means another way of saying this is sort of a ratio of 1 to 1. This is drawn life size. The head over here is drawn 5 to 1. That's 5 times life size. And the little poop that you see in the corner there, that little scat, you see the scat originally done 1 to 1, right? And then an enlargement of it. And I didn't measure that. So here's how this works. You're thinking like, how would you calculate all this stuff like 5 to 1? I'm going to just jump over to the Nature Journal Wonder Thrill Cam here. We have, and I'm going to show you how to do these this 5 to 1 thing. It's super, super easy, right? Let me see. Actually, first, just a few more pages like this so you can kind of see that this is, I'm doing this all the time. So this leaf over here, this is done 1 to 1. So that's drawn life size, right? This is 2 times 2x. That's another way of saying twice as large. So this is doubled. 3x is tripled. And so that's another way of communicating that same information. If you want to do it with the x, right? So, but how do you figure out if it's 5 to 1, or so if this is 5 times bigger, this is 3 times bigger. You can write it whatever way feels like the most tasty to you. Means the same thing. But let's check this out. Actually, maybe there's one more. Oh, yeah, here's more. So these little guys in the middle, life size. Thing above them, life size. There's a plant there, 5 times life size. How am I calculating that? And I'm glad you asked, because I am now going to go over to the thrill cam. All right, here we are. Bum, 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 bum. Acorn. You've got an acorn, right? But you're thinking, like, how could I get all the detail on this acorn in a drawing that is life size? I want to draw this acorn bigger than life. And so you're going to like, okay, it's going to come up here. It's going to be a big acorn. And in this scale, I can sort of show how this crack forms here, how this little piece kind of comes curling out there. And then it's got this little thingy, this little root starting to kind of come in there, and more of a flattened top. So I've just drawn it larger than life, right? Now I want to have something, I can do this several ways. One thing I can do is I can put my little guy next to, it's the whole thing is 4 centimeters long. So I could do it this way. I could draw a little line out this way, a little line out this way, draw a line around here, and say that this is 4 centimeters, right? Measurement made. Or watch this. I could go from here to here. That's 1, 2 and a half. This is magnified 2.5 times. See what I did? As that's 1 acorn, 2 acorns. I use the real object as the unit of measurement, right? And it's 2.5 times, and that means I've magnified this 2.5 times. Boom, you can now use the object that you're drawing as the unit of measurement to figure out how much you increased the scale. But it gets better than this, doesn't it, Fiona?
It does.
It does. And I'm not quite sure because I'm not. What's coming next? We'll go. Let's go find out. Let's jump over to back over there, because we can measure things. Play. All right. So there's some measurements. Yep, there's some more measurements. Because we were just talking about, sometimes it's big. And so this is where this whole area of biometrics comes in. So I'm going to explain the first part of it, and then Fiona's going to walk you through the second part of it. What you're doing is you want to measure your body, and you're going to use your body to measure the world, right? So you will be a geometer, a earth measurer. You're going to turn your body into a geometer. And so what is cool about that? So the inchworms, that's the family. That's the order. I think, or they're geometrid moths. And that means earth measurers. As their little inchworm is walking around, they're measuring the earth. So you can do the same thing with your body. So if you know how tall you are, you can use yourself to help you measure a tree, right? But if you don't know how tall you are, you can't do that. So measure yourself and write it down. Another thing that you can do is measure your own personal cubit. Fiona, could you show everybody what a cubit is?
Yes, it's measurement from your elbow to your fingers.
Yeah, I think, and is it with the fingers straight, I think.
Okay, so then elbow to your fingers with your fingers straight.
Yeah. So, or if you can do it, you can also could do it to your fist, just so long as you know that you're always doing that, right? When you're using your thing, yourself to measure, you're always got your fist closed or you've got your fist open. You also want to measure the shoes that you most commonly wear in the field, so you can measure something by going toe to toe to toe to toe to toe to toe, right? Walking toe to toe to toe is really slow, though, right? It is slow to walk toe to toe to toe. So, what we do is we figure out our pace. Ooh, and this is where it's going to get cool. And I was working out the math of this, and then I had to call up Fiona. So I'll walk you through the first part, and then we're gonna, and Fiona will walk us through the second part. The first thing you're going to do is you're going to get a big old measuring tape, and you're going to measure out either 100 meters or 100 feet. So find a flat space, and what you're going to do, Fiona, can you still see my on your screen? Can you still see my my little piece of paper?
Yes.
All right. So here's what you're
Jack,
going
if
to
you
do.
stop, Jack, can you stop your slideshow so that we can see your picture bigger? Because right now you're pretty small.
Very small. Oh, it's me over here. All right. Stop share. Is that better?
Yes, that's better.
All right. So here's what you're going to do. This is the ground, and this is you standing there on the ground. All right. Yay. All right. And you're going to measure out here 100, and you get to choose whether you're going to go metric or imperial. And I am going to suggest to you to just make the jump, go metric, right? And it's going to be weird at the start, but then you'll be like, I'm so glad I went metric, right? Say goodbye to converting inches, feet, and yards. Let's just keep it all with tens and tens and tens and tens. It's so much nicer. And what you're going to do is you're going to get a little measuring thing, and you're going to start walking over here, and you're going to be walking towards this, and you want to just start with step number 1, kerplop there. And you're going to count the number of steps from here to there, right? And so I usually start back here, so I kind of get into my regular walking rhythm, so that when I hit this, I'm kind of going with my regular walking gait, not big jumpy steps, just your normal way of walking. And then do it back the other way, and then do it back the other way, do it several times, average them, and you're going to get a number. You're going to get a number of steps to go 100 meters, right? You do it several times, you're going to figure out what your number is. Let's say it took you 157 steps to go from here to here. You now know if you want to go 100 meters out, you're going to go 157 steps. But what we're going to do is we're going to use this number to actually calculate a whole bunch of other really useful things. So for instance, if I wanted to figure out how far to go 50, what I would do is I have 157, and I'm going to divide it by 2. Right? So you can do it the old-fashioned way, or you can get out a calculator. But either way, it's gonna be good, right? Let me show you other things you can do. So you can get your 100 meters is X number of steps. I'm using the letter Y, so we don't confuse Y with multiplication. I'm just using Y. Y is the number of your steps. So to get 50 meters, that's Y divided by 2. 10 meters is Y divided by 10. And 1 meter is Y divided by 100. So do that math in advance. Write it down in your journal. Whoa, come back. Right? Write it down in your journal. And then let's say you need to go 12 meters out, right? You're going to take your 1 meter distance and multiply that by 12. Now you know the number of steps to go out to go 12 meters. So cool, right? So if I want to go 10 meters out, if I want to go 30 meters out, I'm going to take my 10, I'm going to multiply it by 3. So if I get these numbers here, those are going to help me in the field really kind of quickly figure out, in order to go a specific distance to out, I can use these. Now Fiona's going to walk us through what we can do to say, like, how far is it from here to over there? What do we do, Fiona?
All right, so if you like ratios, you can set it up as a little ratio of your number of steps that you took over 100 meters, and then is equal to 1 step over X meters, and solve for X by cross multiplying. Or you can just, it's a lot simpler, you can just have X as your number of meters per step is equal to 100 meters over your number of steps that it took you to go 100 meters. So from there, you can calculate how many meters or what percent of a meter is in one of your steps. So then you can figure out, let's say you've gone 20 steps, you know how many meters that is.
That's cool. So if I know my 1 step and it took me 20 steps, I take my 1 step number. This is an incredibly useful number. I multiply that by 20. Boom, I have that distance in meters. Oh, that's so cool. Right? And if you want to, ahead of time, figure out your number of steps for what you get for 1 step, 10, 50, and 100, you can do that. Right? But the most kind of critical one is to what you can calculate all of those if you have your 1 step. Right? So things that are you can't measure with your little ruler, you're getting the diameter around the base of a big redwood tree. You're doing your steps around there, and that's a really cool way to do it. So now let's go over to the Fiona cam, and she's going to show us about measuring angles. So
yes,
show us that interesting tool that you have.
Here it is. This is a goniometer. It's am I here now? Okay, I was being told that I was not. Okay, so this is a goniometer, and the cool thing about this is you can use it to measure angles. So on this side of it, you can see there's little numbers. I don't know if you can see them if they're upside down for you, but there's little numbers around here. And so if you want to measure the angle of something, you can hold this part level with the ground. Let's say you want to measure, like, if you're using angles to find the height of a tree, if you're going to use trigonometry for it, you can line this up with the ground and then line this up with the top of the tree. And then you can look here, and on this line is whatever angle it is. So that's really cool. I believe Jack sells these on his website. No? Anyway, but they're really, really cool. And I suggest that you get one.
Yeah. So yeah, they're made for physiotherapists to help people kind of get the motion in their joints. What is your degree of motion in your joint? So yeah, those are really, really cool tools. It allows you to be. If it turns out that if you have a tool that's designed for like once you put your ruler in your backpack, you'll start measuring things. Once you put a goniometer in your backpack, you're going to find that you start measuring angles, right? So here I am. This is me sitting in the middle of a field, or by the side of a pond. The sun comes in from this direction. I use my goniometer to check the angles to different mallard ducks. And what I found is that depending on the angle from the sun to the mallard, the color changed on those ducks. And so this is then a graph of how that color change worked. And like, so right at 90 degrees was where where they right at 90 degrees is where the change from blue to green really that shifted. So that's kind of fun. So if you have something that allows you to measure angles, you'll start to see angles in places that you didn't before. Boom. Now, what about timing things? Ooh, this is fun. Take it away, Fiona.
All right. So this is a journal page from 3 years ago now. There was an eclipse that I watched and journaled about. Oh, this was so long ago. So I got up pretty early before it started and set up my scope so that I could see through the scope and have it projected onto my paper, and was drawing it from there. And so I was noting at different times what was going on. I think I checked it like every 15 minutes or something like that. Yeah, it looks like I checked it every 15 minutes, and then making little notes about what was going on. At one point, all the birds stopped singing when it was like really getting dark. All the birds stopped singing. It was really, really weird. And then at around 10:45, the birds started singing again, which it was really, really crazy to like watch it get so dark and like everything was quiet. It was really cool. Anyway, so yeah, there were all the shadows started having little like fingernail shapes. They were all like mini eclipses. It was really, really cool. Sorry, my dog's barking. Um, so anyway, that was a really fun thing in terms of time and watching it as it went almost full cover and then all the way back off again.
Yeah. And then you did the same thing here, but stayed up late.
Yes, this I actually got up before school at 4:50 in the morning. This was a lunar eclipse. This was a little more recent, and it was just crazy the color that was going on. So I decided I was going to paint my whole page black and write all of my observations and questions in white, which was really fun. So I started at 4:50 and I checked it um, at 5:05, at 5:15. So I'm writing down the times next to the little drawings of what color it was and what it looked like. And yeah, anyway, so that was really fun, and timing it and watching it um, as the color changed and the sun started to come up. It was really, really beautiful.
Yeah. So quantifying those times, the time units here, seeing like about 5 minutes apart in here at some points, and yeah, 5 minutes, 5 minutes, 5 minutes, 5 minutes. Now this is for something that is moving quickly. You're checking at shorter units of time. With a plant that's growing, I'm checking this iris growing about once a day, right? Actually, this first one was, um, let's see. So this one here, um, yeah, this is at 6 a.m. And here is the same flower, right, at 8:30 that day, and same flower at 7 o'clock, 7 p.m. here. So it's one flower 3 different times. So then I follow that over time, and it kind of blooms and it wilts, and then another one starts to come up, and then that other one comes in. And so you can see that following that through time, you get to pick the time intervals that are become relevant. Down here towards the end, when the rate of change is slower, I check in with it less frequently. So August 8th, 11th, then the 20th, then the 28th. So 8 days later to get from there to there, because the rate of change is going to determine how often you're going to check in with something. Other things you can do is you can look at behaviors and time them. So I am looking at this bittern and its hunting behavior. It's catching bullfrogs and fish and sometimes missing things. But because I recorded that this was over 20 minutes, I can actually convert this to a success rate over time, because I have an activity over time. I can turn that into a rate. So if you, for instance, if you calculate how many times a bird pecks in a minute, you have pecks per minute, right? If if you time the distance that a banana slug travels in 1 minute, you have centimeters per minute. So what you can do is you can take another measurement, another metric, and relate that to time as well. Just here are some other from other people's journals in the Nature Journal Club. Jasmine Ray was looking at Jupiter's moons every night, checked out those positions of the moons. This is the same thing that Galileo did to discover that those moons rotated around the sun. I mean, around the moons rotated around Jupiter, rather than everything rotating around the Earth, which was the common thought at the time. And for that, it was heresy and almost lost him his head. But nobody threatened Jasmine because she's cool. And now we're a little bit more down with kind of accepting that we can make observations of the natural world. This is one of the sketches that Galileo made of sunspots on the sun, and he did the same thing over time and discovered that these rotate around the sun. So all these things, we can be very, very specific, right? We can count something and we can say there are 5 ducks, but sometimes we have a hard time counting things precisely. Fiona, what are some examples of things where you can get specific and other places where you have to estimate?
Yeah, definitely like fields full of birds. Like if people have been to the Central Valley in California when there's sandhill cranes, there's often just like so many of them. And it's impossible to like sit down and count them all and not lose track of where you are, or the snow geese too in the Central Valley. If there's like a few flowers in your backyard, like on your lawn or something like that, you can count dandelions on your lawn. But it's really difficult once there's so many things to count. And so estimating has been really useful. And yeah, it's a really useful tool for understanding kind of how all of that works.
That's right. How many geese would you say?
I would have to say 2.
Yeah. When we're at these sort of numbers, we look at it and we immediately know what we're talking about. But it doesn't take long. We're still good, right? You look at this, your brain immediately knows what number you're talking about. But what about here? Don't count them. What's your gut? Now count them. Right? Were you right? Were you wrong? What about that? Ruh-roh, right? How on earth can you do this? Right? So one way of doing this is to group count. What you can do is you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hold your hand out, point it towards the screen as if you're grabbing 10 of these birds on the screen. And then go back and get the next 10 and say, there's another group of 10, there's another group of 10, there's another group of 10. So how many groups of 10 does it take for you to go back there in your screen? Right? Now, let's take that unit. Let's say you go like, hey, there's 10, that's 20, that's 30, 40, that's 50. Hold your hand out and as if you're physically grabbing 50 birds. Physically grab 50 birds on the screen. And now chunk count, kind of group count. Go, there's 50, there's 100. There's 150, there's 200. There's 250, there's 300. Now put your hands around that big group of 300 and go, there's one group of 300, there's another group of 300. So what you can do is when you're estimating things, you can kind of get your estimation to be a little bit closer by kind of chunking these things instead of having to look at it and say, well, I think that's 2,000 birds, right? That's not going to get you very far. I was doing a Christmas bird count with a number of amazing birders. You'll barely be able to see these little birds on the screen. These guys would walk up to a field and they would say, oh, wow, in that field there are 4,000 snow geese and 2,500 Canada geese, right? And I was impressed. I was thinking like, wow, You folks are amazing at estimating these things. And then I started wondering, like, how accurate are these people in those estimations? So I was trying to get them to say, like, all right, let's go on this one field over here. Let's everybody estimate it and keep your number to yourself and just tell me what they are. I wanted to see if everybody was coming up with the same numbers, and they didn't want to do it. They didn't want to do this little exercise because it'd be scary to, anytime you're practicing something but without able to kind of have a way of then at the end of the day ground truthing whether you're right or not, you get increasing confidence in your estimations, but your level of accuracy doesn't go up. But because you practiced it, you get more confident in it. So you get so what happened then, finally this flock of snow geese flew by, and I had a photographer take a photograph of it, and while the birds were in the air, I told everybody in the group, you have to estimate the number in this group and whisper it to me. And so you see those dots? I want everybody to sort of chunk count those, kind of go, there's 10, see if you can kind of figure out what is 100 in this, and then kind of chunk count this. I want everybody to kind of come up with an estimation for how many snow geese are there. And I can tell if you're actually looking at your screen. Right? So, what I did then is I went back and we counted these dot for dot. Each color stripe here is 100. Right? So there's 100, 200, 300, 400, 500. And so the actual count of these was 2005. The estimates that the people in this group had averaged around 1,200 birds. So, but they were all very sure of their estimates. So, but this is something you can get better with with practice. Anytime you have a chance to estimate something and then be able to ground truth it and find out how many actually were there, it is awesome to do. So, Fiona, do you have one of those in the journal? Could you hold up the page that has the little dots?
Yes.
The little dots. So what we've done is we have made a little kind of estimation helper. If you want to kind of get in your head, like, what does 100 look like? What does 1,000 look like? So Fiona, say something and it will jump over to you.
Okay. So this is a little handout in the back of Jack's journals that he makes and that will be back in stock soon. And this is basically, so like, here's an example of 1,000 dots. So like, to give you an idea, that's 1,000, that's 100, that's 50, that's 10, that's 500. So you can kind of get a sense for what these numbers look like, kind of in like random dots as you would see in the sky with a flock of birds or something like that.
And another fun thing about that, if you don't have that book, this is also a free download from my website. So I think we've got them on both stickers that we can download them onto and then print them out onto Avery stickers, or on a sheet that you can glue into the back of your nature journal. And so you can get those there. So those little estimation helpers help you be able to kind of like, oh, that's this, kind of get those, kind of chunk those numbers in. So go to johnmuirlaws.com, go to the store. There's a bunch of free downloads. You can print out rulers onto stickers and from that page, and then stick those stickers with the ruler on it into the back of your journal. So you've always got a journal. You've always got a ruler with you. There's a sheet that looks like this. It's got a protractor. It's got these percent cover things. It's got Beaufort wind scale, which we'll be talking about in a moment. It's got rulers and things. So all of that, that's a free download that you can take this and print it out into your journal. So you get this kind of quantification helper sheet. Let's just play a little bit with estimating some numbers. So what I'm going to do is I'm going to put up a screen, and there'll be dots on it. And what I want you to do is just kind of like get a gut hit of how many are there, and then chunk count them to get a more accurate estimation. Then I will flash the number on the screen. Okay. So get a gut hit. What does that feel like to you? Is that 100? Is that 50? Is that 10? How close can you get to it? Now notice, because I said the number 100, that forced everybody in the group to anchor higher. When you are in a group of people and somebody says a number, that number will influence dramatically your estimating. All right. Avea, give me a thumbs up if you've got your estimate. Ready to go? All right, here we go. That's what 50 looks like. Oh, score! All right. All right, so yeah, and everybody who gets it, you have to go, whoa! Okay, now this next one is going to be more difficult. All right, so what I want you to do is just initially get a gut hit of what you're looking at. Then chunk count it. And what you're going to find is you will tend to either go high or you'll tend to go low. The more you practice it, the more you'll kind of really be able to kind of get in on sort of what your thing is. At the Department of Fish and Game, I meant to kind of put the URL of it. They've actually got an estimation. They've got these pages where they'll show you a big flock of geese, and you try to guess how many are in that. I'll try to get that. If somebody can find that and put it into the chat, that would be groovy. Otherwise, I'll put it on our Facebook page. That was 100. How'd we do? 100. All right. Let's try this one. All right. Try it again. Just what does it feel like? And then group count it. They're about to fly away. What about that? So tempting to try to count them all, but what we're trying to do is just sort of figure out where our kind of internal quantimeter is doing. What does your internal quantimeter say? I undercounted that one. And the last one. Oh boy. So in this, try to get 50 and then count by 50s. And here it comes. How'd that go? All right. So we've got some. So you can do this with everything. There were some fish and game people who I went out to visit at a refuge, and they had a game that they would play at night where they had a sheet where they would throw beans on the sheet. And there were graduate students out there, and they would put a known number of beans on the sheet, and everybody would try to estimate what that was. And then they would count the beans, and they'd see who got the closest, and they were betting on it. And it's sort of like their sort of a game that they played was with these white beans on a black sheet. All right, now let's try it with these. How many birds? Don't count them all. Try to gut it, and then chunk count them. This is kind of interesting. There's some recent research on aerodynamics that's gone on, and people have been wondered for a long time. Sometimes when you look up in the sky, you'll see these skeins of geese coming across, and you'll see one side will be a lot longer than the other. You'll regularly see this. And do you know there's actually a reason behind that? Do you know why that is? Yep, more geese on that side. Sorry. All right, that was 28 geese. And we'll try this last one. Notice what your general sense of it is, your gut feeling. How many are you looking at? And then chunk count them. And here they come. Here's the number. Get your idea in your head. And that was 343 geese. All right, so you actually can get better at this. And when you can do this, like try this just with people at a bus stop, right? You go by Crissy Field Lagoon and you see a bunch of geese out there. Just sort of say, there are this many out there today, right? There are this many ducks that are in that flock. And then chunk count them. And your general estimating sense will get more accurate with your sort of counting. And then if you can be really specific and anal retentive and count them all, then you can get it dialed in even more. The more you practice it, the better you'll get. And you'll find that your estimations improve and improve and improve and improve. But if you just are making estimations, but you don't have any way of ground truthing it, what will increase is your confidence that you're right, but not your accuracy. One last note on these: if you see roughly 450 snow geese, and in the next pond there are 7, in our nature journals we don't write there were 457 snow geese, because that implies that you counted every one. What you want to do is keep the rounding on your estimates close to whatever units you were using. So if you were counting by 50s and you saw 450 snow geese, and then you see 10 more, you saw 450 snow geese, right? If you see 20 more, you saw 450 snow geese. If you saw 50 more, right, then you saw 300 snow geese. So you want to keep your rounding units, they will show the degree of accuracy of your estimations, right? So if I get down into sort of place values that are so fine that I'm really making stuff up, I want to replace those with zeros. And now, a few final fun little details. Let's start with wind force. Do you want to walk us through this, Fiona?
Sure. So this is a really helpful little chart to kind of estimate the wind and what kind of force it is. So this is the Beaufort wind scale. That's how you pronounce it? Yes?
Yes, that's right.
Yes. Okay. So 0 is just calm. And this was all created for people in the ocean and on ships and stuff like that. So a lot of it is relating to the ocean. So in light air, so smoke will drift. So then, et cetera, light breeze, leaves move, and you can feel the wind on your face. So it's really, really helpful for things like, especially when you're on the coast, because you can, for the white caps and stuff like that, and the size of the waves and whether flags snap in the breeze, whether there's leaves falling, whether there's trees falling, when it really gets up to high wind. But yeah, anyway, it's a really useful little scale to sort of estimate about how many miles per hour or kilometers per hour the wind is going.
Yeah. The scale actually goes all the way up to 12. But by the time it gets to 12, you should not be out nature journaling. So I only kind of put in this little chart, only kind of kept the practical ones. This chart with these pictures in it is in the new nature journal that I'm printing out. And at some point fairly soon, I will make a downloadable free version of this, have that on my website. Currently, there's a text version that is available of this chart in the free download that's currently available on the website. But I find it is helpful to have those little pictures, and you kind of see like, oh, leaves moving, small twigs, small branches, small trees moving, then big trees moving. You know, you can kind of get these points, and what's nice about it is that the units in it are at a scale that is useful for kind of that you can notice, right? So this is it's a very useful thing to have. The next little strategy is estimating what's called percent cover. Right now, there are a few clouds in the sky, but if I wanted to say how much of the sky is covered with clouds, I want to use what's called percent cover. If I wanted to say how much of the rock is covered with lichen, if I wanted to say how much of the whale is covered with barnacles, and be able to compare the percent cover under the whale's chin and on its back, I would want some way to estimate percent cover. So the way I do this is, like, let's say right here, how much of this sky is covered with clouds? Huh. It's hard to say, isn't it? Well, this is the way that we actually have a fighting chance of doing that, right? And what it is, it's a percent cover chart. And we've got a free download of that. It also is available as a sticker set. So you can print these out, put them on stickers, stick those into your journal. So here you can sort of see like, oh, this is what 10% looks like, 20%, 50% looks like. And so what I'll do is I'll hold these charts up, these bubbles up to a screen, and then say to myself, like, oh, all right, I think it's roughly this. And it helps you to be a little bit more precise instead of just sort of say, there's a lot of barnacles. There's not quite as many barnacles. So with that, what percent cover is this? Let's first kind of look at this. Look at this. Look at this. Look at that. What do you think? What about this sky? Now let's go back and just check this out. This out. Write down your numbers. Back to this, taking a look at that percent cover, and this. So this one here was 15% cloud cover. Oops, you can't see what I'm doing. Let me try that again. This is 48% cloud cover, this little image. This one here was 15. This one back here was 73. But we can get much more precise and accurate with practice. But we don't get better if we're not practicing this. Final little kind of fun bag, a little tool here. A lot of us were playing with this during the solstice when we were figuring out how high the sun was with potatoes. And we said that the sun is 10 degrees, 20 degrees, 30 degrees above the horizon. Well, there's actually a whole set of things that you can do to figure out, like this is 5 degrees. What you do is you stand with, if you imagine that all around you is 360 degrees and you want to figure out how far that planet is from that planet, right? Or how far the sun is above the horizon. What you do is you stand with your shoulders square to that horizon, and you can put your, if you say with 10 degrees, that's a fist on the horizon. Another fist above that is 20. The next one is 30. Or you could go by 25, 50, 75, 100, right? So different hand positions give you different, at full extension with your shoulders square, give you different portions of the degrees of arc of the 360 degree circle around you. Another thing that you can do, like if you notice with me, I measured that my hand flat is a decimeter. You can actually do the same thing with this. You can figure out for use, you know, how many centimeters your shaka is, right? And write that down. And for me, it's 21. So I can now measure, there's 21, there's 42, there's, right? So you can measure using this both degrees of arc, or you can also use these for some, you know, you can use these to add to your biometrics. For me, this Boy Scout sign is 5 centimeters. So 5, 10, 15, 20, 25, 30. All right. So I can use another way of kind of extending my biometrics on a small scale. My pinky is about a centimeter, a little bit bigger. So if you have printed one of these that has this on it, you can write into the middle of the hand how many centimeters that is for you. It's another place to record your biometrics.
Just to let you know, Jack, I have to leave in like a couple minutes for class.
Oh, all right.
Just to let you know.
Let's now we're going to just jump on to visualizing data. All right. And we are going to, you're getting these numbers, and you want to start including those numbers in your journal. You can do that in a bunch of ways. And what we're going to do is I am going to fast forward to the part where I've got some journal pages of yours, Fiona. So just everybody, ignore everything you're seeing right here. You don't need to know anything about this. Ah, there we are. We'll come back to that other stuff in just a moment. But while Fiona is here, Fiona, you invented a way of collecting quantitative data, and it's shown on this page. Do you want to share that with people?
Yes. So this is actually the page that I created this little thing on. And Jack calls them Fionographs. They're basically, I use them mainly when I'm looking at flowers, and variation in color. So you can see it's right below my little metadata box. So I was noticing that there was variation in this certain owl clover that I was looking at. And so I made a little color swatch for the darkest pink that they were, and then a little bit lighter, and then some of them were white. And then I looked and I made little hash marks next to all the ones that were dark pink, medium pink, light pink, and white. And then I was able to see what the most common color was. So it was that kind of medium pink, the second one, that was the most common color. So that's really fun. I do that a lot in flower season, making these little graphs with the little color swatches and then how many of each color there are.
Also, can I say mad thoughts for the flowers, thought balloons and voice bubbles? Those are really fun. Very stealable idea. Also kind of shows where you're making an enlargement of something. But I also just like that little flower saying, I don't need to bloom. The one with the stamen coming out of the closed bud right there. That's outstanding. What sticker ball are you from? This is fun. I think we've got another example of that. Here's another Fiona graph, and also another.
So this is Love in a Mist in my neighbor's yard that I was looking at, and there was some of it that was white, some of it pale blue, some of it dark blue, and then some of it almost purple. And so I went through and looked at some of the flowers and got a little set of data over there. It's on the right side of the page. And that's my other little Fiona graph. This is a page from a long time ago. But yeah, anyway, so it's been really fun to use.
There's another little chart here that is on the left-hand page. Tell us about what you're quantifying there.
I believe this was petals. Yeah, it's petals. So number of petals per flower. So they had everything from 5 to 20 petals, with 12 being the most common. But yeah, so I went through and looked at some of the flowers and counted how many petals they have and made little hash marks next to the number. So that's another little thing that I do.
Yeah, and because you're kind of keeping the vertical, like as you move out to the right, you're kind of keeping the same rough places on those. You can read it like a histogram of what are the most common types of. So it's a little tally histogram here for displaying that data. That's really cool. So this is another page that you did. And you notice that this is, so you're saying, but she's not quantifying things on this, not yet. But I want you to know that, so she's looking at these wildflowers close to a pond. And first of all, there's some spatial data, the stuff that was closest to the pond on the left, and things that were further away from the pond on the right. So as you were drawing these, you were collecting some spatial information. And now I want everybody to see that there is a color box that is associated with each one of these. Now, Fiona, take it away and explain what is going on. So those colors, remember those colors, that relates to what you're seeing here.
So I went crazy with quantifying here. So I drew a little overhead map of the pond on the upper left. And so I painted in the areas of where the flowers were with the color in that box on the other page. So you can see I forget which color corresponds to what. I think the pale green is like plantain. So I was painting the areas that I saw the flowers with that color on my little map. And then I also made a little chart of the numbers of flowers and what percent they were. And then I made a little pie chart with what was the most common flowers. So clover, plantain. There were very few of the thistle. There was more of the chicory, morning glory. Anyway, so I really went to town with all my data, and my total flowers surveyed were 2,697. So anyway, I had a lot of fun.
This is really cool.
And I have to scoot because I have class at 1:15.
Fiona, thank you so much for being with us. Everybody send it up for Fiona. Thank you so much for being here, Sketching Buddy. I will see you soon. And thank you for those lovely little oranges that you sent me and the girls. We're really enjoying them. Thank you very much.
Thank you so much for letting me be here. Thank you.
It was great to see you. So when you do this, patterns will emerge to you that you otherwise would not see. So what you're doing is you're allowing yourself to see patterns that otherwise would be invisible to you. That's huge. Here's another example of, if you look over here on the right, here is the length between this node here and this node here of this flower. So this distance from here to here, from here to here, from here to here, from there to there. In these pictures, you can see it's growing over time. And then it seems to have slowed down. This is the actual measurements with the date on this day. These were the measurements that I took. This is how much it grew in that day. So multiple measurements on one day in this poppy. But on this little graph here, I just lined all those up, and you can see the growth curve and how it flattens out. So sometimes you can take your own data, you collect something like this, hard to visualize. So what we also are in the business of here is trying to get ourselves to take the data that we have and to convert that to something that we can look at and understand and intuit. That leads me to this next idea. So one last big idea, and then I'm going to let everybody go here. But I want to show you folks stem leaf plots, because if you are doing any kind of quantification in your journal, you are going to want to know about stem leaf plots, because these are absolutely brilliant, crazy useful thing. Allow you to do statistics without having to calculate the mean and the standard deviation. Let's say you're looking at the height of a flower growing in the forest. And like Fiona does, you're sampling a bunch of different flowers. You're looking at the height in centimeters of all these flowers. So the first one that you look at is 25 centimeters, the next 38, then 63. You could put them in a table, but I want everybody to notice you look at this table and your brain goes, right? We can't really make sense of that table. We don't have any sense of what is the core of this data, what's the central tendency of this data, and what is the spread of this data. So here's what we do. Instead of collecting it this way, 25, 38, 63, I make this little chart. We're in the forest, 0, 1, 2, 3, 4, 5, 6, blah, 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 blah. This is the stem of my chart, and here are the leaves. 25. So for 25, I go in the 20 column here, and I put the 5 there. 38 is here. 36 would be there. 49, 43, 54, 63. So if I get another 41, I'm going to put it right over here next to the 3. And I'm going to try to keep these columns straight. So let me just kind of go back here. So 24, 38, 63, 54. Right? There's 63. There's 54. Right? You see how this works? This is absolute gold, because you keep putting in these measurements and it draws the picture of your data. It turns your numbers, it keeps all your raw data, so you still have what your raw numbers are, but it has organized them into a picture of the data. This is mind-blowing. This is the statistical mic drop of the day, right? This is a really big deal. You start to use this, you are thinking statistically. You're thinking about the means and the standard deviation of this without having to do any calculating them. You understand what this is like. Now, let's say we go up to the ridge top where the wind is just howling across and we measure the same plants. What I can do is here they were at the ridge top. Oh, it looks like there's some smaller numbers, but what does that really look like? Well, let's go back to this, put the ridge right over here, and put that data in. So you see what I'm doing? So this is 40. Sorry, this is 4. This is 7. This is 4. This is 16, 16, 18, 10. This is 24. What I'm doing is I'm putting the leaves out on the other side. And what this allows me to do is to compare two populations. Now, you could do a statistical test to kind of assess the difference of these means, or you could look at this picture and you immediately know what's going on with this data. Do you like that, or do you like that? You make the call. I like this one too, Avia. I'm like, oh yeah, I'm going to do that, right? This is absolute gold. So here's a slightly similar thing that I just did with X's. I am looking at this plant this oak that's been munched by deer. And there are some leaves growing in a skirt at the base of it, and others growing at the top of the tree up here in the canopy above deer level. And I noticed that they seem to be larger leaves up here. So this is life size, 1:1. And they were smaller leaves down here, 1:1. So big leaves, smaller leaves. But look how many spines this little one has on it. So what I did is I made a modified stem leaf plot where I just put in number of spines and just put X's, kind of like a tally histogram, to kind of build up. Up high, they have fewer spines, even though the leaves are bigger. Down below, one little leaf even had 21 spines on it. So in the deer zone, they're spiky. Isn't that cool? This tells that story. Another way of sort of showing that. Just a couple other examples from the Nature Journal Club of people doing some beautiful data visualization. This is Kim McNett. She is up in Alaska ice skating on glaciers and frozen lakes in front of the glaciers. So if you want to learn more about her, Marley Pfeiffer just interviewed her. Go check out the Nature Journal show, and you'll find an awesome interview with her. But check out what she's doing. Look at this visualization. It's a map combined with numbers. And what she's got here is showing positions of the glacier from old satellite photos and data at different times in the past. So this was where it was 1996, 2012, 2018. This is it today. So this is data. These are numbers. And by having those dates, those numbers in there, combining it with a map, it tells an amazing story of glacial retreat. Really powerful. Oh, and check this out. This is her ice skating by these icebergs that are frozen into the lake. So much fun. All right, so a nature journaler, Alaskan ice skater who is documenting glacial recession. Boom! I like it. All right, check out this. All right, this is beautiful data. Beautiful data. Right? Julie Tennis is looking at this creek in Washington. The blue is the rainfall levels. The brown is the height of the river. And then above that, she's doing sort of meta thinking about it, right? What she's interested in, what she's noticing, what's going on at these different points, right? These patterns would be completely invisible to her if she just took data tables, or if she just made subjective, notes and observations of it over time. But because she's got this, She graphed it. She drew a picture of it. She turned it into a picture. She now understands these really interesting dynamics of the relationships between. She has time on the bottom, and then you can look at what she's done with the graph. So on one axis here, this is river height, and the other is rainfall. So you can she's got three things going on. She's got a three-dimensional graph here. She has time, water in the rainfall, and water in the river. I mean, that's beautiful data. So steal this idea. Steal Kim's ideas. Steal Fiona's ideas. Share your own ideas with other people in the Nature Journal Club, and let's find ways of really using these numbers as another beautiful language to express how crazy the patterns are on this planet that we all share. It's an amazing place. But some of the patterns, we have to really do some spelunking to be able to find them. And when we do, it's so much fun. It's so beautiful. So thank you, folks, so much for joining us today. This is just a deep dive into, sorry about that. This is full half hour over our allotted time slot, but I got carried away. We kept Fiona out of class for a while. But I hope that you got some really good strategies and ideas, and that this inspires you to start to play with those numbers in a more dynamic way in your own nature journal. So now I'm going to turn over to the community cam, the Nature Journal community cam here. And if you've got anything to share with either quantification in your own journals that you think would be neat for other people to share, or a journaling page that you've been working on that you are excited about, or you've got questions or comments for the community. If you've got a nature journal page that you've been working on that you wanted to share with other people, just hold it up to your screen. Sort of make yourself visible, hold it up to your screen. I'll scan over the screen and I can see where people are holding things up. Let's start by jumping over to Melinda Nakagawa. She's our co-host, and she is the curator of the Monterey chapter of the Nature Journal Club, and does some amazing nature journaling programs through the Monterey Bay Aquarium. Melinda, thank you so much for helping us out, and thank you for sharing what you've got with us today.
Yeah, thank you, Jack. This was really great. It's always good to look at numbers, and I have a science background, so I always love seeing numbers, but bringing it in a way that's fun and accessible to everybody is really valuable. So I was hearing in the chat that some people had some number anxiety, and this was really fun. So thanks for putting this together.
So if we can take people from number anxiety to people who are going to be evangelists for decimeters.
Yeah.
Then we have advanced this world in this
Absolutely.
1 hour and a half.
Yes,
yeah, please.
Yes, that's right. Well, I wanted to share something that happened last night. So during one of my nature journal classes, I have a student, actually Jenny, who is the director of the Whale Museum, hopped on the call and said, Melinda, right now, this is what we hear in the hydrophone. So there were humpback whales singing when she got onto the class. She came 5 minutes early. And so I immediately grabbed my nature journal and started drawing the sounds that I was hearing. And it was the most beautiful singing of these whales. And, just the singing of humpback whales is really moving. But to know that in that moment at 6 o'clock in the evening, that up in Johnson Strait at Orca Labs in Vancouver Island, that humpback whales were singing into the microphone. And so I felt like that moment was just so powerful. I had to put whatever I could on the page. So I just made marks of what it sounded like. And I wrote down words to describe, there was this like ethereal moaning and a trill and roaring like a lion, a squeaky gate, a bloop sound, a questioning sound, and just wrote whatever was coming to me. So as my students were logging into the class, we just stopped and said, and Jenny was going to turn it off. I said, no, leave it going. So that became our lesson. It was actually perfect because we were going to focus on our senses. And so just, sometimes just being open to nature can teach us so much more than we ever anticipated. So, there were students that were really moved to tears just listening to the whale. And I think that with nature journaling, we're training each other to pay attention to nature, not only through our eyes and our scientific mind, but through here,
Yeah.
right? To feel the sound of the whale. It's not just this marine mammal that's in the ocean. We're vibrating in this way that we can't express, but we can only feel it if we have been paying attention. So what Jack is talking about, what I'm talking about, what other nature journal teachers are teaching are the tangible tools to get you closer to nature. And from that, world opens up for you to connect to nature with your heart as well as your mind. So I just thought, if you get a chance, go to, she said the seasound.org, SEA sound, SOUND.org is the Whale Museum page. And there's a webcam as well as a hydrophone. And she said sometimes you can see the orcas going by and listen to them at the same time if it's during the day. So if you want to do some nature journaling with your ear and draw it into your journal, check it out.
Oh,
Thanks.
wow. Melinda, I can still hear the tenderness and emotion in your voice. What a moving experience. That's absolutely beautiful. And thank you so much for sharing that with us. And also your passion for stewardship. That's so it's really beautiful. Thank you.
Thanks,
And
Jack.
so what the lines that Melinda has, it's that little kind of line. There's actually a lot going on in that. What she's got is frequency, the pitch, high and low, over time. So if something goes, that's a line that is going high and down and up, right? And this is quantification. That's you've got that's wonderful. Thank you so much. Let's see. If you would like to share another journaling moment or page, please just hold it up to your screen. Oh, Mary, good to see you. You've been playing with some leaves, I see. And you are currently muted if you unmute yourself.
Host is, you know what? It says host is not, oh, you can't hear me.
I can hear you.
Oh, I can. We're loud and clear now.
There was a problem there. Okay, we're getting our very few leaves left on the trees. This is when autumn really starts to feel a little sad and melancholy because there's very little of the beautiful colors left around. So I took advantage of what was around and I was inspired by, I guess it was Tuesday, and I made a couple watercolors.
Oh, and that fun ones with flip up, where you've got both sides of the leaf. That's great.
You were supposed to show the other side. This one only has a little bit.
But doesn't that little curl over make so much of a difference? Mm-hmm. And also I noticed like how you have the shadow right in that point lifting off the page, and you see just that little bit of light under the arch, and it just pops that part of the leaf up. What an ode to the end of a season. Oh, Mary, this is delightful.
We hate to see this go.
Yeah.
There we go.
And our challenge is then to find in that gray time that comes after it, is to train our eyes to find the beauty in that as well. Oh, yeah. And so I have a special challenge for you, Mary. And that is like sometimes like if you get a little project that you can geek out on, it makes things because it becomes so interesting, it becomes really, really fun. And so what you can consider is, while we're waiting for the reappearance of leaves, is in this in-between time to start looking around for, are you on the East Coast?
Yes.
Right.
Yeah.
To start looking around for two things. One is, what are the shapes of the leaf buds on the different kinds of trees? And if you really want to go down the rabbit hole, the shapes of the leaf scars. So in the place where the
Yeah.
leaf has fallen off, there are these little marks that are left behind on the branch, and some of them make little faces. And each type of tree has its own special leaf scar patterns. And if you really go bonkers on those, that can hold you through until those leaves reappear.
Okay.
Oh, those really, I feel like those leaves are just resting there on the top of the page.
Well, that's why I like to do those little shadows, because it gives you like a excuse me, trompe l'oeil
Yeah.
effect. Yeah.
And what's also interesting right now is just the lighting in your house is perfect, such that the real shadow of your hand is the same value as the shadows you put on the paper. And so it actually looks like you're have taped those on the page, because the shadows are actually coming from the projected from the same direction as the current real shadow and the value of that shadow. So that's a real that's a fun little moment.
Well, I find if you keep the value nice and light, they, for some reason, I think they look more realistic, at least in certain, I don't know.
Yeah.
It just seems to, for me anyway, it works better to keep the value. They don't steal the show or something. I don't know. It works out well.
Yeah. There have been and also a little bit of color in those shadows goes a long way. So if it's not just charcoal gray, but just a slight little hint of shadow color, that's really fun. Thank you so much for sharing that, Mary.
Thank you. Well, thank you for the class.
No, it was a fun one today.
Fun one. Yeah.
Let's go back to the community cam. Ray Bonto, it is good to see you again, my friend. I am going to spotlight your journal page.
Hi. So it's like that. That's for the numbers today.
Yes. Oh, great. Yep, and it opens up just a whole new door for ways of quantifying your observations.
Yeah, and the one I'm hiding at the bottom is because it's the second one. So I drew an oil bird today, directly in pen.
Oh, whoa, ho. And so you dove in directly with the pen. That's really exciting.
Yeah, I used a ballpoint pen because you can make really light lines with it.
Yeah, I love those for the same reason.
One which I stole from my dad. Yeah.
Oh, that's a nice value range. Going all the way to dark to those light shades. Yep.
And again, thanks for the Goniometer you sent.
Absolutely. I hope you get some good use out of that. And now you've got more ideas of perhaps ways of using it. It's a fun.
I do have some cool leaves.
Oh, are you going to draw and paint those in your journal?
Yeah.
That's a good one. I like the contrast between the top and the bottom surface on that. Oh, that one looks like it has galls on it.
Yeah.
That's cool. I wonder what organism made those galls. Those will be good ones to
I
include in your.
did sketch this already, but it's not part of the show though.
Not part of today's show. Well, if you ever feel comfortable sharing those, we'd love to see them. Thank you.
Well, I haven't got it here. I could share it on Tuesday if you're
I'll
doing
look forward to it. I'll look forward to it. And I also want to see your sketch of that yellow one by Tuesday.
Yeah.
Do you think that one will be done by then?
Yep.
Okay.
I had a question. Are you doing Ask Jack? Because this time you did leaves and there wasn't any question time. And it wasn't really an Ask Jack. Are you doing Ask Jack or have you changed it to something else?
Well, no. What happened with the last Ask Jack is that before the class, I had just done a workshop for a bunch of school children, and in that I made up a bunch of those techniques, like moving the leaf and then dropping the pencil down. And I was just so excited by that. Like during the class, I'm like, oh, you can do this. And then I thought, like, I should share this with other people. And so while those ideas were still fresh in my head, I just turned over and taught that as a class on drawing leaves. But usually Ask Jack is going to be kind of an open workshop and an open session where we'll kind of take orders from the and for folks who missed the leaf the leaf class, I posted it on my website last night. So if you missed that,
have you managed to do that file idea I said? Managed to put the chat file on your website?
I haven't yet, but I've got that. I really love the idea because there's such interesting ideas that come through in the chat, and you really also get much more of a sense of the energy and the connection in this community. I think that's a very good idea. Ray Bonto was suggesting to include the chat as an appended file with those videos.
Yeah, thank you.
Hey, thank you. Really good to see you again. And if you, let's go over to Nicole. Nicole, I am going to spotlight your video.
I wasn't going to share it at all, but when I saw Ray Bonto's ink drawing, I thought I'd share this technique that I'm working on. I did it by accident the first time. So I use fountain pens a lot. And there's different inks. Sometimes they move and sometimes they don't. And I had mixed a blue ink with a black ink. The blue is water soluble, the black is not. So I'm able to do things like just take water and highlight stuff, or to put in shadows with just a water brush. This is actually you with the light bands across your face. You're at a 1:10 ratio approximately. But yeah, with Ray Bonto's ink drawing, I thought I'd share that to see if anybody else wants to give it a shot.
See, Ray Bonto, you're inspiring us. So Nicole, let me get this right. You are making your own mixture that you put in your fountain pen, and you're combining a black and a blue in there in one pen. Is that correct? Or are you taking two different pens?
Yes. It's one pen, and I have there's a company called Noodlers, and they make what they call bulletproof inks that don't move at all when they get wet. And then I just had some extra blue that was from a sample that I added to it because you wouldn't notice it, and it was just extra ink to make it go further. And then I got it wet and noticed that the blue moved and the black didn't. And I've been able to get some really interesting stuff from it. Like I was doodling a little bird that I was able to give where the different gradients of light and dark coloring was. And like I said, just highlighting different stuff that I found interesting.
And this is
just with water.
A refillable fountain pen, right?
Yes. This one, actually, the entire barrel is filled with ink. So it lets you take a lot of ink with you too. This was a very inexpensive fountain pen. I actually got this one free with one of the bottles of ink.
Oh, that's great. What a cool idea. And
so it was totally an accident. I love it.
This is the Nicole technique. You heard it here first. That's a great idea. That's a really great idea. Thank you for sharing that.
Thank you.
All right, let's see what else is going on here. Ivea, so good to see you again. During the talk, I could see you. The computer randomly chooses like different people to be kind of visible to me in the corner, and you're up there at the top, so I could hear you see you going like. I can see when you got the estimates right. I'm going to spotlight you, and here we are.
Thank you. Yeah, whenever you or Melinda or anybody talks about numbers, I get so excited because for me it's a little bit like it's like discovering a brand new candy all over again, because I used to think numbers were pretty, but I didn't really get them, and you all make it accessible to me. So this class makes me really, really happy. I'm probably going to watch it later on like a feature film and just be like, ah!
Make some popcorn and watch numbers.
Yes. So this was from on Sunday with Melinda's class, where we were doing skyward salutations, and so we'd done some stuff about clouds and whatnot, and then we'd done the 4 directions activity where you look in the direction and you paint what the sky looks like, which was super duper fun. But of course, looking at the clouds made me think exactly what you were showing us earlier with, percent coverages. And this is something that I want to practice more to do in my restoration. So I'm trying to think about ways to do this. So anyways, after class, on Sunday, I was way too, like, just too much going on, too many exciting things. So I was drawing this one feather, noticing that it wasn't symmetrical, which challenges some of my viewpoints because I'm trying to like look more at nature patterns. So for me, looking at symmetry and lack of symmetry can be really fun, especially because of that technique we use where, you draw half of a thing if it's symmetrical. And then afterwards, I'd begun to do this in non-photo blue pencil, but I was trying to measure fall because only now has the liquid amber begun shedding leaves. But I wanted to measure the percent coverage of how many leaves were on the pavement, but couldn't figure it out until this class. So I wanted to thank you. What I'm going to do is look at the individual squares of the pavement and do a little practice where I paint in how much, and then try to do an overall estimate about what approximate percent coverage is. And I realized the thing that was holding me back was looking at when you see a clump of things where it's a bit denser here and then less dense over here, and then trying to average that. So I'm going to have a lot of fun playing with that and then sort of figuring out what the overall percent coverage looks like. So thank you.
That's cool. That's really cool. I like that.
Thank you. Yeah, feathers.
Yeah. And how you're right, just a little bit off symmetrical. It's kind of symmetrical-ish. You look at it and you first you go like, oh yeah, it'll be symmetrical, and then you do a double take and it's not. Isn't it fun when we get surprised?
I love it. Thank you.
Thank you. Anne Chadwick from Point Blue Conservation Science. Spotlight.
So yeah, thank you. A couple of things. One is also from Melinda's Sunday class when we were looking at clouds, and then the full moon rose that night off, I could see it just out my window and then from my deck. And so full moon rising, and, put in what angle and what time and what date and everything. So this is just white colored pencil and ink on toned paper. So I tried to really minimalize it, but the clouds, it was so cool because the clouds were illuminated by the rising moon, by the reflection of the sun off the rising moon. So that was pretty fun.
Paper.
Yeah, I wanted to sort of not have to do all the work of coloring in the sky. And I thought, well, really, there are just a few white highlights and some black. So just chose that pretty darkish paper. And then I guess it was about a week ago, I went over to the Calusa National Wildlife Refuge in the Central Valley of California. And this is one of a gazillion, to be very concise, very precise about the number. And I actually looked on the website and they estimated there were about 2,200 there that day. And I'm not sure that I saw every single one, but that was one of them. And I looked up a few statistics about they fly at night and up to 77 kilometers per hour. And the longest flight recorded was 2,900 kilometers. And that was a non-stop flight. So putting in some really interesting numbers. And the oldest one that they have on record was recorded in Saskatchewan, 22 years old.
Wow.
So pretty fun to throw in numbers. And that's the photograph that I took that I worked from. And one thing that I'm working on, Jack, is how to get those, what is that? I'm running out of words. Droplet, you know, water drop on it. So you can see I tried to do that. So someday in Ask Jack, maybe we can do like how you capture water drops on leaves or rose petals or ducks or whatever. Because they just
remind me next Tuesday.
Okay.
And we can play with water drops.
Yeah, I mean, I hope other people are interested as well, but I've always just been fascinated by that.
It's really worth it.
Because they do such amazing things with the light. It's just really cool. And they sort of magnify and have shadows and reflections and lots to go on. So those are my 2 pages.
Oh, that's really fun. And what an exciting way to engage with that toned paper, that Bad Moon Arising. Just I can feel it. Are those over eucalyptus or bishop pines there?
Eucalyptus. Yeah.
Nice.
And the other thing I was going to say is that I'm also kind of a wildlife photographer, and I took a gazillion, to be specific, photos, and I will post, and I have a lot of those, like the geese taking off all at once, thousands of geese, and a lot of close-ups like this. So I'll post those to my website and maybe put a link in the Nature Journal Club in case anybody wants to use those for drawing or for estimating or whatever. But that I'll probably do that in the next couple of days. People are welcome to use them.
Yes, that's great. Thank you.
Thank you.
Oh, thank you. That's really cool. And we would love to use those photographs. That would be really fun to see.
Great. Oh, and Melinda asked what my website is. It's very simple, annechadwick.com, ANNECHADWICK. But I haven't posted these yet, so be patient.
All right. Hey, Tracy, did you want to share something with us? Let me add a spot. Oh, this one.
Yep, I finished up my work on it. And actually put it in a frame. Someone might get a Christmas present. I don't know who yet.
Yeah, just this is just so graphically exciting.
Thank you. Everyone says 3D, and I'm like, I didn't set out to make it 3D. But I guess that was the nature of doing that leaf, was that it was 3D.
Yep. Well, and what you've just observed it so carefully, right? So that it makes when you have, say, a curling edge and you're really paying attention to, like, what do those teeth actually do as you wrap around that curl? And for folks who weren't here on the leaf drawing workshop, we kind of get into some strategies for that. It really carves that form. This is so much fun.
Thank you.
Thank you.
I'm going to do I want to do every leaf. I'm going to collect leaves next summer, press them, then collect more from that tree and try to replicate this with other types of leaves. Because I just love drawing leaves anyway.
Yeah.
And watercolor is perfect for leaves. So that's my plan for next year for me and the kids. We'll collect the leaves, press them, collect a fall wrinkly colored one, and do comparisons.
That'll be really cool. Yeah.
We're done.
Not quite done yet.
That's it. That's it. Let's just see. Is there anything else that people wanted to share? Linda. Oh, we've got some, I think, some owl stuff going on here. Let's see.
You'll be surprised. It's not even an owl. I was watching my octopus teacher.
Oh, yes.
Stop it and draw. Okay. So they were kind of quick gesture, and I went to a really bigger piece of paper. But the thing I want to share most, I'll show you all the pictures real quick. So I've only, because they're big and I was trying to tell a story, I was taking notes. Since then, I've learned a lot of better techniques about taking notes, and even the numbering stuff today, I would probably be adding to it, but that's progress for us all, right?
That's right.
Here's some more.
Oh, this is so much fun, and what a great idea.
Okay, well, but the thing I want to most share, though, at the very end of this here, is to do this. I was at the art supply store, and I found this water-soluble graphite crayon. And that's been a game changer for me as far as doing this kind of stuff, and then going back in and hitting it with my paintbrush a little bit to kind of just kind of make things happen. But it forces, because it's kind of fat and awkward, it forces me to not be fussy. Because the thing I'm combating most is getting through my sacrificial pancake period quicker. Okay, so and as much as I don't want to be addicted to beauty, I am a little bit, because when it gets into the flow, it's just naturally beautiful, and you don't even have to try, but you have to get through that little thing at first. So anyway, and I wasn't even going to share this, but Ray Bonto, you little bugger, when you were sharing your ink drawing, it just made me like, oh, I have to dig this out, because it just seems like important right now. So there you go. Thank you.
Thank you. Thank you. So that's really fun. And what an inspiring, beautiful movie that was.
Oh my gosh. I've watched it 3 times, and we have a diver. We have octopus out in the waters on, across the street in the Hood Canal. And we have a diver that is a National Geographic guy that posts his stuff online. And the octopus there is not a little baby guy like this. It's a hugie. So anyway, good. Thank you.
Absolutely. Oh, thank you for sharing that. That's really fun. And that idea of that little Lyra pencil, such a.
Yeah, that's right.
While watching my octopus teacher, I sat down with the girls, and we don't have a television, but I've got the projector that I use for presentations. And when we want to kind of make an event out of something, I set up a big screen in our living room, and I take the projector that I use for presentations and hook speakers up to it, and we make popcorn, and we sit down, and it's an event. So and so we did Octopus Teacher together, and so I was taking some notes during it, and so I've got 3 quotes that so if you haven't done this, normally I'm not recommending to people go inside and watch a movie. But this is beautiful. It was inspiring, a real work of art.
Oh my gosh, yes.
And so here's a quote from it. People ask, why are you going to the same place every day? But that's when you see the subtle differences, and that's when you get to know the wild. All right, another one. What she taught me was to feel that you are part of this place, not a visitor, and that's a huge difference. And the final quote from that movie, I fell in love with her, but also with that amazing wildness that she represents. and how that changed me.
Yeah. And you could feel he changed. It was really raw. If you haven't watched or listened, Terry Gross interviewed him, and it's so insightful to hear how his story of creating if you took the notes on this, you probably are like hooked by the guy. So it's a good ride. Anyway, thank you. Thank you so much.
Thank you. Thank you. I'm going to try to get a hold of him for a future Wild Wonder. We'll see what we can do.
Yeah. I hope so.
All right, my friends. Thank you all so much for, actually I need to go double check to make sure that I have not skipped anybody who wanted to share something. But thank you all so much for being here, for being part of this community and sharing in these experiences together. You just in this conversation here, I feel like the threads of ways that we, here we are, all these people in our homes scattered all across this country and this world, are connected to each other and find inspiration in each other and support in each other. And for me, during this strange and sad and isolating and confusing time of COVID, I want to let you folks know how grateful I am to you, and for the sort of generosity of spirit with which I see us supporting each other and reaching out, and connecting with each other through art, through nature, and I think this this community here reminds me of what is really so beautiful in the potential of our species, and thank you. All right, my friends, I'm going to go make Amelia a late snack. She had to wait for it this time. But thank you all for being here, and I will look forward to seeing you all again soon. Take care of each other, take care of yourselves, be safe, and be kind.
Thank you so much.
Thank you. Bye.
Thank you.
Jack, we love you.
Bye. Thank you.
Thank you.